Hi everybody, welcome back to my channel, Numbers with Nora. This is a math tutoring channel that helps you with all your math tutoring needs. For this video, it's going to be my third video on statistics. We're still in chapter 1 and I'm in lesson 1.2, assessing your understanding. With this video, we're just going to be doing a lot of practice problems. The last video I did, I kind of went through definitions, examples, and like how to really understand this section of the chapter. The book that I'm using right now is going to be Statistics by Michael Sullivan, 3rd edition. If you need more help on trying to find this book or how to find the PDF version or a cheaper version of it, just leave a comment below and I will tell you where to find it. Okay, so I'm going to go ahead and jump right into it. I'm only going to be doing the even problems because I know in the back of the book they have the odd problems. But if you want to see the odd problems, just let me know. So let's go ahead and jump right into number 10. All right, so to go over what they want from 9 through 16, they say determine whether the study depicts an observational study or an experiment study. And how we can depict this, it's more in my last video. Observational study is basically a study that is plain and simple. It doesn't break any study into any groups or anything. It doesn't have any other like complicated experimental variables. I used a plant example in my last video. You can refer to that. And also in the book, there's another example. But basically, plain out basic study where all your individuals are the same and have the same characteristics, and then all your experimental variables are kind of the same. All right, and then an experimental study is when you're going to have different like groups and stuff like that and section off your individuals. All right, so for 10, it says rats with cancer are divided into 2 groups. One group receives 5 milligrams of a medication that is thought to fight cancer, and the other received 10 milligrams. After 2 years, the spread of the cancer is measured. So we have to sit there and pick if it is observational, experimental. This one, 100%, because we sat there and split it into 2 groups. Remember, like I said, groups are dealing with experimental. All right. So I'll put E for experimental for this one. This one's going to be experimental. Right. So let's go on to 12. All right. For 12, hair and heart disease. A study in which balding men were compared with non-balding men are at point in time found that balding men were 70% more likely to have heart disease. All right, we have to pick if it's experimental or observation. So for this one, again, because I can just study all men with heart disease versus balding men and men that have hair. So since I'm picking out those 2 groups, it's going to be experimental. All right. All right. So let's look at 14. For 14, 200 people are asked to perform a taste test in which they drank from 2 randomly placed unmarked cups and asked which drink they prefer. So again, it's kind of weird because they say randomly placed cups and unmarked cups, and then it's random drinks. We don't really have a specified group, right? So since there's not a specified group and they said 200 people and it's just random people, they didn't say if they're women or men or if they are people from New York or Los Angeles. They didn't classify, they didn't put groups. So I'm going to sit there and put O for observation. Okay. And then 16. Conservation agents netted 250 largemouth bass in a lake and determine how many were carrying parasites. So this one's pretty straightforward. No groups, no sectioning. I'm not sitting there saying what kind of bass they were or what weight they were. So that's just going to be observational. Okay, O for observational. All right. If you have any questions from 9 through 16, let me know. All right. So let's go to the next one. So for these ones, it's applying concepts. So it's giving you real kind of cases or statistics examples or experiments that have been conducted, and we have to sit there and choose from A through D of what they're asking us, what they are. For this one, I'm only going to do 18 and 20. If you want to see the other ones, leave a comment and I will give you the answers for those ones. So right now, let's focus on 18 and we'll focus on what they're asking us. So 18, is there association between daily coffee? Okay, so we have daily coffee consumption. I always love to annotate and understand when they give you like writing in mathematics. You always sit there and take annotations. So is there an association between daily coffee consumption and the occurrence of skin cancer? So occurrence of skin cancer. I'm underlining those because those are my possible variables. Okay. Researchers asked 93,676 women to disclose their coffee drinking habits and also determined which of the women had, oops, sorry, excuse me. Drinking habits and also determine which one of the women had non-melanoma skin cancer. The research concluded that consumption of 6 or more cups of caffeine per day, again, this is a time. So whenever they give you a time, you want to be considerate with it and underline it. So you consider if it's a long time or short time or so forth, was associated with a reduction in non-melanoma skin. All right. So let's go ahead and answer the questions that they are asking us. 18 is the first one. All right. So this one, what type of observation study was this? Explain. So in my last video, I went over the types of observation studies, and there's 3 types. Okay. So there's going to be, oh, I should do a text box so I can go a little bit faster. Just a second. There we go. That's better. All right. So there's 3 types of observation studies. There's cross-sectional. It's cross-sectional. I don't want any space in that. That's fine for now. There's cross-sectional. And then there's case control. And then there's cohort. All right. Again, in my last video, I sat there and went through these and have the definition in those for those. All right. So first of all, this one, cross-sectional are basically, and I can go up and show my notes from before. Cross-sectional studies are observation studies that collect data about individuals over a certain period of time. So this one, we do have time involved, okay? So that's why I would sit there and consider cross-sectional, because they sit there and say daily. Okay, that's like a key hint, right? So this is going to be cross-sectional. And it's just because time was involved. It gave us a time period. Time. Just the time. All right. So now let's look at B. Oops. Oh, it's not going to let me draw. That's okay. So now let's look at B. So what is the response variable in the study? So remember, we sit there and have response variables and explanatory variables. Response variables are basically how in your study things response. Okay, like in my last video, I used the example of the plants. And so you have plants and you want to study how they're growing based on a fertilizer. How they grow is the response, and the fertilizers would be the explanatory of why they grew. All right. So in this case, um, the response, and I'll put R for response. The response variable is going to be skin cancer. Okay. Because that's what happens. Okay. It's skin cancer. Skin cancer. Sorry, there's no, that looks really bad. Should have done the text. Skin cancer. Okay. So that's your response variable. And the explanatory variable is why the skin cancer happened. That's going to be because of coffee drinking. Okay. The daily coffee consumption. We'll just put coffee drinking. We'll just put coffee drinks. Okay. So that's going to be the answer to B. Is it going to let me highlight? Now it lets me highlight. Okay. And now let's do C. In the report, the researchers stated that after adjusting for various demographic and lifestyle variables, daily consumption of 6 or more cups was associated with a 30% reduction um, prevalence of non-melatonin skin cancer. Why was it important to adjust for these variables? All right. So we want to sit there and see why it was important to sit there and move things around for those variables. So basically adjusting for variables that may have not been considered are going to basically consider, again, in my last video, I told you about variables like these that may not be considered in your study, but may be important for your study. And these two types of variables are going to be confounding, and I'll show you for my last one. They are going to be these two, confounding variables and lurking variables. Okay. Sorry. So it's going to be confounding. And I'll put lurking, and I'll tell you why in just a second. Lurking. All right. And basically, that's because this one, why was it important to adjust for these variables? It's important to adjust for these variables because it just makes sure that there's more accuracy. Because when later on in the chapters, we're going to start doing more math and statistics and start looking at number stuff. But when you don't account for these variables, it makes your readings or your answers more precise. But when you do include them and basically they kind of throw off your answer, it's going to make them more unprecise. That's the basic way to put it. So that's why. All right. If you want to see number 20, because I'm running out of time on this video, let me know. And leave on the comments and I can write it down word for word and what the answer is, okay? And if you guys need any more math help with statistics or any other math needs, just let me know. Thanks, guys.